Hi, Assalamualaikum and greetings to Madam Dr. Anis. Today we will be presenting our group project on fuzzy logic dataset titled Fast Food Nutrition. So here is my group member, me myself, Nino Fatina Shah binti Usin, and will be continued by my two other group members, which is Nur Akila binti Aminuddin and Nur Afifa Inshira binti Muhammad Tabarani. We will be discussing two content today, which is dataset and fuzzy logic. So let's get into the introduction of the dataset. Fast food eating is becoming more common in modern life. Its ease of use, low cost, and widespread availability make it an enticing option for many people. However, excessive fast food intake has been related to a variety of health problems, including obesity, heart disease, and diabetes. Furthermore, fast food processing and packaging frequently contribute to environmental problems such as waste and carbon emission. Fast food is well known for its convenience and low cost, but it is also notorious for its high calories, fat, and sugar content. So, in this dataset, it intends to shed light on the nutritional worth of certain fast food products, assisting customers in making more educated eating choices. This dataset, which includes information on calories, fat, carbs, protein, and other vital nutrients, is a significant resource for nutritionists, researchers, and health-conscious consumers. We may acquire a better knowledge of the nutritional impact of fast food intake by evaluating this dataset and working to provide healthier food alternatives in the fast food business. So now, let's get into literature review and summary. So the first is fast food consumption behavior among college students, a case study in Tinsukia. The study looked at college students' meal choices for fast food goods in Tinsukia. The research-dependent variable was food preference, and the study contained 5 independent factors. The study included 50 participants, and the hypotheses were tested using regression analysis and chi-square testing. The second one is fast food consumption, a problem among adults in Malaysia, an analysis of the National School-Based Nutrition Survey 2012. The study's goal was to look at the factors that influence fast food intake among Malaysian teenagers. The study looked at socio-demographic parameters, body mass index for age, meal routine, and food category intake as potential factors impacting fast food consumption. The next journal title, Multi-Criteria Food Products Identification by Fuzzy Logic Methods. The research looks at the use of fuzzy sets in the food business for multi-criteria food product identification. The authors compare fuzzy and probabilistic classifier, their essential distinction, and application region. They show how to utilize fuzzy indicator function to determine product qualities and give examples of how to apply fuzzy logic. So that's all for my part. Let's continue with Nur Afifa Inshira.
Okay, thank you, group leader. Hi, my name is Nur Afifa Inshira binti Muhammad Tabarani. My metro ID is CA20115, and I will continue the presentation for the methodology and fuzzy logic rules. General fuzzy logic has 4 components, which are rules, fuzzy-fair, inference, and defuzzy-fair. Fuzzy rules establish a set of fuzzy rules that relate the input variable to the output variables. Fuzzy rules consist of antecedent, if condition, and consequence, then action. For example, a rule for temperature control could be if temperature is cold, then increase heating output. The first step is Scripps input, also known as pre-processing, which is the process of conditioning the input variables to be measured before they enter the fuzzy logic controller. Scripps input are binary value inputs. That is, either the answer to the statement is 0 or 1. In a simple way, it is defined as either true or false. It only has 2 values, just like a binary. Then, a fuzzy-fair is the step after the Scripps set of input data has been gathered and converted to a fuzzy set using fuzzy linguistic variables, fuzzy linguistic terms, and membership function. Fuzzy-fair plays a crucial role in transforming Scripps input values into fuzzy representation, which form the basis for fuzzy inference and reasoning in a fuzzy logic system. This step assigns a membership degree to each fuzzy set based on the input value by evaluating the degree of membership for each linguistic level using their respective membership function. Following that, an inference is produced based on a set of rules that include all the rules and if-then condition proposed by the expert to regulate the decision-making system. Based on the fuzzy rules and the fuzzy input values, we use fuzzy inference technique to determine the appropriate fuzzy output. To generate a fuzzy output, the inference process combines the fuzzy set and their membership degrees according to the rules. The fuzzy set will then be defuzzifier, which is the process of converting fuzzy set into crisp values, which is crisp output. It is also classified as post-processing. Using a defuzzification method, we turn the aggregated fuzzy output into a crisp value in this procedure. Defuzzification strategies that are commonly used include centroid, maximum membership, and weight average. To compute the crisp output values, this approach takes into account the shape and membership degree of the aggregation fuzzy output. Okay, now let's see the membership function, the fuzzy logic graph. Okay, this is the example of dataset for the input. This is the colors input, fat input, sodium input, and sugar input. Then this is the example for the output. Okay, let's say the input of colors is 6.5, fat input is 9.8, sodium input is 9.8, and the last input sugar is also 9.8. And this is the example of the healthiness output. Then we continue with the fuzzy logic rules. Okay, if the calories is low and fat is low and sodium is low and sugar is low, then healthiness is high. If calories is medium and fat is medium and sodium is medium and sugar is medium, then healthiness is medium. The last rule is if calories is high and fat is high and sodium is high and sugar is high, then healthiness is low. And that's all from me, and we continue with the next person.
Thank you, Nur Afifa. Assalamualaikum. My name is Nurul Akila binti Haminuddin, CA20072. So for my part, I'm going to present the result of the values that we have obtained. So here's the table that has attribute of restaurant, item, calories, fat, sodium, sugar, actual healthiness, and predicted healthiness, where we will be using for the calculation of accuracy value. Here is the formula for the predicted healthiness, which is percentage of predict healthiness multiplied with actual healthiness. Next is the accuracy formula, where actual value minus predict and divide with predict value, then times with 100%. To compare the accuracy of the real and predicted healthiness data, some actual and predicted healthiness data were chosen. The calculation accuracy is high if the result is close to 0%, while the accuracy can be assumed to be inaccurate if the value produced is 15% or higher. Here are the three examples of data sets are as follows. The calculation results lead to the conclusion that the majority of the predicted calorie amounts are accurate. This conclusion was reached because of the data being collected using exact coding or a set of criteria that produce precise estimates. Based on the provided calorie values, the healthiness score could be precisely calculated thanks to the usage of fuzzy logics and established membership functions, rules, and inputs. The careful preparation and testing of the fuzzy logic system is responsible for the precision of the estimated calorie values. It is important to remember that the relevance of accuracy of the membership functions, rules, and input data directly affect the accuracy of the predicted calorie values. The estimations are likely to be accurate if these elements are clearly specified and correspond to established criteria or expert knowledge. In conclusion, accurate estimation of the calorie values have been achieved using exact coding and a clear set of criteria in the calculation procedure. This increases confidence in the accuracy and dependability of the calculations. So for the final conclusion of our project, this project is done based on the fuzzy logic concept, which we chose to make research on fast food nutrition. Fuzzy logical thinking appears to be human reasoning, and it is like how human makes decision as in our project. The decision must be made based on the four inputs, which are calories, fat, sodium, and sugar. And whether it is low, medium, or high, we will change the creeds to fuzzy logic so that we can determine the nutritional value of fast food. We utilize this strategy since the creeds do not provide accurate logic. Fuzzy logic, on the other hand, gives acceptable reasoning while also existing in dealing with uncertainty. And that's all from us, and thank you for watching.